So today is we're going back to exponents, simplifying exponents. Let me give you some recall. Can someone tell me what should I do? So if I have a to the m times a to the n, go ahead, Hart. N plus n. You're gonna stop talking, otherwise, if I talk, nobody can hear you. It take individual effort. All right. So thank you. So if I have a to the m times a to the n, then if I have two same bases, I add the exponent, right? Do not multiply them. I see people do that on the on the group assignment sometime. If I have a to the m to the n, then what do? Multiply. Now I multiply, right? A to the m times n. If I have, let me do a little bullet point here, so that means new one. If I have a to the m divided by a to the n, now assume that m is bigger than n, then what happened? Yeah, you subtract m from n, a to the m minus n. And then the result will be stay on the top, right? If you have another way around, if you have a to the m divided by a to the n again, but in this time, m is less than n, then what happened? That means n is bigger. Yeah, so you're gonna take n, subtract m, and whichever have a bigger exponent, your result gonna stay in that location. So because n is bigger than m, then your result should be stay in the bottom. So it'll be a to the n minus m. Now, today we're gonna talk about why we do this, right? Why we do this. If I have x squared divided by x to the fifth, now according to the rule, the quotient rule, according to this one right here, let me put this back in the top. According to this one right here, that one, the one on the top, then all I do is take n minus n. If I use that one, then I take 2 minus, is it 5? Can't see. 5. Yeah, 5, thank you. But then I got negative exponents. Then what do? Let's simplify. See what is it equal to? If I simplify this one right here, I'm gonna write out x, so x squared divided by x to the fifth. It's the same thing as x times x on the top. And then the bottom is x times x times x times x times x. Do you guys know how to simplify these? That with that, that with that. So what do I have left on the top? 1, good, not 0, right? 1. And on the bottom is x to the third, very good. All you do is add the little ones, so x to the third. Okay, so x squared divided by x to the fifth is 1 over x cubed. So that means, if I go back up here, what does that mean? That's x to the negative 3 should be equal to what? Yeah, 1 over x cubed, right? Because it had to be equal to this, which is this, right? So that you have another rule is that if you have the negative exponents, all you do is you flip it. You flip it and then your exponents turn positive. Number 3. So, do they have a rule here written for you? No, they don't. Okay, let me do like this. Let me do like this. I'll write it out for you. If I have a to the negative m, all I do is, by the way, a to the negative m is basically a to the negative m over 1, right? All I do is flip that 1 and then a to the positive m now. So that's your rule. And it can be explained. Now it can be explained a different way. So let me explain a different way for you. One way is you roll out like that, which is right? It's not wrong, it's just not efficient. So let me explain you another way. Why is that a to the negative n is equal 1 over a to the n? Recall that x to the 0 is equal 1, right? N to the 0 power is equal 1. If I have the expression 1 over x to the negative 4, now instead of 1, can I replace it with x to the 0? Yeah. If you use that rule, let me pull it down a little bit. If you use the one in the double check mark in red right there, I'm gonna take 0 minus 4, so it'll be what? So this one right here, let me rewrite this one. Move it to the right. Run out of color here, so we pick purple. If I'm using this rule right here, this one right here, right, I'm gonna take 0 x to the 0 minus negative 4, right? N minus n. It'll be what? What's 0 minus 4? Yes, 0 plus 4, right? So this is x to the 0 plus 4, which is x to the 4. Very good. So you see that? You see that from here, from 1 over x to the negative 4, all I do is just flip it. So now the 1 is in the bottom because we didn't write it. And then the negative exponents turn positive. Does that make sense? So the bottom line, when you flip something, exponents change size. Okay, that's the bottom line. Right. Okay, so let's do this. Why was do I have to do that one? You don't have to do two. Let's say something. Maybe yeah, I'll say something. Ignore that one. So say when, let me ignore that one. Okay. When this is informal, okay. When you flip the fraction, exponent, it could be plural, changes size. So you have that one, and that one. See that a to the negative n? Make it a little bigger for you so you can see. A to the negative n. By the way, there's nothing below a to the negative n. Which always be understood as what, over 1. Right? If I say number 3, you say what, 3 over 1. It's the same thing. All you do when you flip it, the n changes its sign, which has become positive now. Same thing here. If I have 1 over a to the negative n, flip it. Now the 1 becomes in the bottom. Change the sign. Same thing if I have two variables. If I have a to the negative n over b to the negative m, if you flip the position, then there's exponents change size. Okay. All right. So because of that, let's do some exercise. 6 to the negative 2. If you're uncomfortable, you can put 6 to the negative 2 over 1. And now all you do, you flip it. Put this up here. Oh, how do I make it? There you go. 1 over 6 to the square now, positive, which is 1 over 36. You guys do B. see what you got. I want you to do B, D, and what the C. You do B and C. I'll walk around, see how you do. All the answers should be, if you have an exponent, it should be a positive exponent. We're gonna make this straight. Very good. Moving forward to like F. Wow, good on you. Very good. So let me do it quick. Someone tell me what's B equal. Very good. C. That's it, over 1 or just x to the 12. Somebody got D all the way to F. All right, so D. Now, do I flip 10 and X or just X? Definitely, I can flip something. But do I flip 10 or X or both? Both, very good, because the X, because of the parentheses, right? The parentheses tell you that everybody receiving the -1. So this is, you can do it like that. So this is 1 over 10 to the X to the first, which is 1 over 10 to the X. Right? What about E? Very good, very good. So this one is the same thing as 10 times x to the -1, which is over 1 there, right? So the only thing that being flipped is the x, because there's no parenthesis here. So that is 10 times 1 over x to the first, which is x. So 10 over x. So far, so good? Yeah. What about F? By the way, whenever you see the parentheses, whichever is included, everything flips. Right? Everything is being involved. So that means the 10x is gonna flip. So it's gonna be 10x, and don't forget the parenthesis again, which is 10 squared is, you distribute the 2 into everybody, the 100x squared, right? Sorry. Yeah. You make it smaller so you can see everything. What about G? What about G? There's no parentheses, so that means the only thing being flipped is the x, right? Because the -2 next to x. So that means 1 over 10 stay where it is. Right, so this one is, let me rewrite this. It's gonna be 1 over 10 times 1 over x to the -2. Is that all right? 1 over 10 stays still, but the x gonna flip, which is x squared over 10. Why don't you guys tell me what's h equal? Yeah, just change its position. So y to the 5th over x to the 4th. Done. No simplification here. I'll let you do I. No, leave it positive. We want everything to be in, well, not everything, to exponent to be positive. So the only thing being moved is actually the -2, right? Even move it downstairs, then what happens to the top? Yeah, 1. And keep the y cube. Do you have any question? Please ask now if you have question. Anything at all. Reminder, if I have a, b parenthesis to the m, then what do you do to that exponent? Yeah, if I have a, b parenthesis to the m power, then what do I do? So you distribute the power, right? So a to the m times b to the n. So same thing with the quotient rule. If you have a divided by b, you do the same thing. You distribute the power into everybody. The only time you cannot distribute the power is when what? Do you remember this? If I have a plus b to the m, is it equal to a to the m plus b to the n? To the n? Is it true? No, right? Do not do this. That is wrong. No. Same thing with the minus. If there's two terms are being connected by plus or minus, do not distribute the power. You can check with a real life example. Let's say let me don't write this down. I don't have enough space anyway. It's a 3 plus 1 square is the same thing as, don't write this down. 3 square plus 1 square. No, right? This is 4 square, 16. 9 plus 1 is 10. So 16 is not equal to 9. So or you can write it down, doesn't it? So, okay. So remember that. Don't distribute whether add or minus. Recall the quotient to power rule. So this one right here, let me highlight it so you can know what to study. Remind me about the exam review. Okay, I'm gonna say something about that. Remind me if I forgot. Now, what about the negative case? Oh, I'm sorry. Maybe let me erase that so that I don't cover anything. What if I have a over b to the negative n? Well, you do the same thing. You distribute the power, right? You distribute a to the n over b to the a to the negative n over b to the negative n. I mean, you flip using what you learned before, right? Usually, what I do this. Let me highlight in green now. Usually, this is what I do. For me. So for you guys, according to you learn, all you do is distribute that, and then later you use a flip rule to flip it to become a positive exponents. For me, I do this. I flip the inside. And then once I flip, I know the outside exponent must be positive because I flipped it. Which is equal to what? If you notice this one right here, if you flip it, it'll be what? B to the n over A to the n. Is it the same thing as this? That one on the right side? Yeah, right. If you distribute the n, right? So you can do that. You can flip inside, and then you still have a big parenthesis outside, and then change your exponent to positive. I'm not gonna say anything about McCray. So maybe I'll write like this: a to the negative n over a to the negative. I mean b to the negative n is equal. You already know that. Oh, that's what I was talking about. The same thing I talked about above. Okay, so let's do this. So this one right here, one way you can do is you can distribute that. So 2 to the negative 2 over 5 to the negative 2. And now you flip. So 5 squared over 2 squared, which is 25 over 4. Thank you. Or what? Or what? You flip right away. You can do that, right? Whichever way I'm showing you both. And now distribute. So whichever way, it's the same thing. Which one you like better, the red or the green? The red is, you don't have to remember much. Red or green? Should I do red or green? Because I don't feel like doing both for every single problem. It's let's do let's do red first. Then maybe we change green later. All right. So okay. So distribute. So 2x parentheses to the negative 4 over y to the negative 4. Make sure you have parentheses, right? And then now you flip. So y to the 4 on the top and quantity of 2x to the 4 on the bottom. Y to the 4. What 2 to the 4 equal? Don't tell me it's 8. Very good. Now, when I ask you to flip, the only thing you flip is a fraction. Everything else stays the same. And change your exponent to positive. You don't touch this. If I do the second, maybe I'll do this. Let me do this. I'll do this, the red one, red method still. If I do the red methods, then I'm gonna attach the negative to the 1. It doesn't matter which one you attach to, really. You can attach to the 5, but I'm gonna do this. Is that okay? You can attach the negative to the 5, doesn't matter. Flip. Tell me, is it right or wrong? Tell me, is it right or wrong? Is it right or wrong? In terms of representation. Because what I'm saying, from this step to this step, what I'm missing. You're gonna get the correct answer at the end, but you we get lucky for D. But you may get lucky here, but something wrong here. What happens with the negative in front of 1? What I say, when you flip, everything else, all you do is change position. Everything else stays the same. And the exponent changes positive, right? So you're not supposed to remove the negative. The only negative you move is for the exponent. Right? So that means that -1 is still there. Of course, -1 parentheses square is going to be +1, because you got lucky if you missed that negative. But you won't be lucky on part D. So part D is the same thing as -1 times 1/5 to the -2. So basically -1 is all by itself outside. It has nothing to do with the -2 exponent. -1 times 1 to the -2/5 to the -2. And then you flip. I'm doing this for the sake of the note. So 5 squared over 1 squared, which is -25, yeah? That's what I meant. You won't be so lucky for D if you remove the negative. What should I do, E? What should I do first? I'm gonna use the green method. Now, there's many ways of doing this. One is that you can distribute the power all to there. Up to you. But maybe I'll show you. Maybe I'll show you a simple way. Okay, so one way I can do is I'm gonna take care of the inside first. So outside is still -2. What 2 cubed equal? 8. And what's 5 squared? 25. And now I flip, right? Now 25/8, and then turn positive. I'm telling you, I'm doing the green method. Right? So I flip negative exponents, turn into positive exponents, and now I distribute the square. So 25 squared and 8 squared. What's 25 squared? 625. Thank you. 8 squared, 64. This one odd, one even, so you cannot simplify. Now, other students can do this. Orange or salmon, whatever you want to call it. Other student can do this. He or she distribute the -2 to the exponent. So it's going to be 2 to the -6/5 to the -4. And now they flip. So 5/4, 2 to the 6. 5 to the 4 is the same thing as 625. And 2 to the 6 is the same thing as 64. So it's same answer. Whichever way you like to do. Okay. You know your rule well, then it's okay. Last one, and then what do you try? Is 16 being flipped? No, right? It's outside the parentheses, so you just rewrite it. So 16 times. I'm gonna use the. Can I do this to the 4? All right, so equal 16 times y to the 4 plus u over 2x parenthesis to the 4. 16 times y to the 4 over 2 to the 4 is 16, right? Mhm. And then you can cancel. 16 is the same thing as 16 over 1. So y to the 4 over x to the 4. Do you have any question before I give out you try? Last chance. Okay, simplify. 7, no parenthesis, times x to the negative 8. Remember, no parenthesis. Hmm? All right. Objective 2 is similar-ish. Now it's just a little slightly more complicated, but you know all the rules before. All you do is just combine them together and what to do what first. Right? So for example, if I have x to the negative 3 times x to the negative 7, what do? Recall again. At least you know this part. Yeah. It's the same rule, right? You have two bases, all you do is add the exponent. And now what? X to the negative 3 plus negative 7, which is x to the negative 10, which is the final answer. Yeah. So you kind of combine the rule together. I want you to do B and C on your own. I'll walk around, see how you do.